So students, our today's topic is analysis of deodorants and antiperspirants. As we know that most of the deodorants and antiperspirants contain aluminium as their active ingredient, and aluminium is mainly present in them in the form of salts like aluminium chloride, aluminium chlorohydrate, aluminium sulfate, and aluminium zirconium salts. So antiperspirants and deodorants may contain aluminium chloride, sulfate, and other metals like zinc, copper, lead, cadmium, and nickel, etc., which are present as impurities. So analysis of different metals in deodorants and antiperspirants becomes necessary, that what they contain. Now, for the analysis of deodorants and antiperspirants, we use a technique which is known as atomic absorption spectroscopy. So before studying the analysis of individual elements by atomic absorption spectroscopy, today I am first introducing you to the new technique, atomic absorption spectroscopy. As the name is suggesting, atomic absorption spectroscopy. Atomic mean related to the atom. Absorption mean absorption of something. Now spectroscopy mean interaction of the electromagnetic radiations with the matter. So atomic absorption spectroscopy basically means that interaction of the radiations or electromagnetic radiations, I would say more appropriately, with the matter. But now in this case, what happens? Matter is made up of atoms. So basically atoms absorb the radiations or heat radiations. So that's why it is given the name atomic absorption spectroscopy. Now what is atomic absorption spectroscopy? Atomic absorption spectroscopy is a very useful technique for the quantitative determination of different metals present in trace amount in liquids. Quantitative mean we are determining their quantity, in how much amount. So it is a very useful technique for the determination of amounts of different metals present in trace amounts in liquids. And trace means very small quantities, and it can detect metals even at concentrations as low as 1 ppm. 1 ppm ppm here means parts per million. So this is atomic absorption spectroscopy, and it can be used for, in addition to liquids, it can be used for solutions and solids also. Liquid here I mean to say, although liquid and solutions are almost same thing, but liquid is generally used for pure liquid, and a solution mean any liquid containing metal ions. So if any metal is present in a solution, it can be detected by using atomic absorption spectroscopy. So next I am coming to the principle of atomic absorption spectroscopy. Atomic absorption spectroscopy is based on the principle that when a sample is subjected to higher energy thermal environment here means heat. When a sample is subjected to heat, the atoms in the ground state absorb radiation of a specific wavelength and get excited to higher energy levels. What is the principle of atomic absorption spectroscopy? That when a sample is subjected to heat, then the atoms of the sample get excited from the ground state to the higher energy states by absorbing heat radiations. But now there is one thing, that one element absorbs one wavelength. So we can say that one element absorbs at a specific wavelength and other absorbs at another wavelength. So this is the main point here. as one element absorb at one wavelength and another at another wavelength, so we can determine the quantitatively the amount of a metal present in a sample. So by measuring the amount of light absorbed at a particular wavelength, we can determine quantitatively the amount of a metal present. Why? Because as absorption for each element is specific. Specific here means that if we are having different metals, then say one metal will absorb one wavelength and another will absorb at another wavelength. So I can say that absorption for each element is specific and no other element absorb this wavelength. Now in atomic absorption spectroscopy, sample is taken in the form of aerosol. What is aerosol? Aerosol mean solution or suspension of a solid or a liquid in a gas. Mean we are suspending a liquid or a solid in a gas. So aerosol mean something like a spray, and the sample is taken in the form of aerosol or spray and is then converted into atomic vapors by the use of a flame. Atomic vapors mean vapors of atoms. The atomic vapors absorb light of a specific wavelength and atoms get excited to higher energy levels. Then the intensity of light absorbed by the sample is proportional to the concentration of the element being analyzed. So this is the principle of atomic absorption spectroscopy. Next I am coming to the instrumentation. Instrumentation mean what are different parts of the atomic absorption spectrometer. So basically a atomic absorption spectrometer consists of a nebulizer, burner, monochromator, detector and recorder. And the schematic diagram of a atomic absorption spectrometer is shown in this picture. You can see at the base sample is there, and the sample from the sample chamber is then passed into the nebulizer. Now what is the function of nebulizer? Nebulizer converts the liquid sample into a fine spray or aerosol. So here I am first showing you the schematic diagram, then I shall discuss its working. So you can see it is having nebulizer, which I have marked with orange rectangle, and then it is having a burner to produce flame, and the sample in the form of aerosol or spray is passed on to the flame where it is volatilized. Then what will happen? Sample will absorb light or flame or heat, sorry, not flame but heat from the flame, and then we are having a monochromator marked in blue rectangle, and which is then connected to detector marked in green rectangle, and which is finally connected to a recorder in olive blue rectangle. So now I am coming to the working. So I shall discuss working of each of part of the atomic absorption spectrometer one by one. So first part is nebulizer. So first step in the atomic absorption spectroscopy is the atomization of the sample. Mean you will have to convert the sample into individual atoms. So for this, the liquid sample is first converted into fine spray or aerosol by using a nebulizer. So what is the function of nebulizer? Nebulizer converts a liquid sample into a fine spray, and then the sample in the form of aerosol is fed into the burner. Then burner, what is the function of burner here? Burner is used to produce flame which generates heat. Heat, or I can say thermal energy, then volatilizes the sample, and the sample is then decomposed to produce gas phase atoms and ions. And the flame commonly used in atomic absorption spectroscopy is fed by fuel gases like acetylene nitrous oxide combination, or we can use air acetylene combination to produce higher temperatures up to 3000 degrees Celsius. And next part is monochromator. Monochromator is used to get light of specific wavelength, as it absorbs lights of all other wavelengths. Means it will convert a beam having more wavelengths into a beam which is having only single wavelength. So function of monochromator is to get a light of specific wavelength. Next is detector. Function of detector is to detect monochromatic light and converts it into a electrical signal. Then the electrical signal detected at the detector is recorded by using a recorder. So recorder records the electrical signal and converts it into a readable data. So these were different parts of atomic absorption spectrometer. What are those? Nebulizer, burner, monochromator, detector and recorder. Next I am coming to the advantages of atomic absorption spectroscopy. Main advantage of atomic absorption spectroscopy, which in short is pronounced as AAS. So main advantage is that it can detect metals at concentrations as low as 1 ppm. So it can be used in different applications like determination of metal ions in biological fluids. For example, in medical field, it can be used for analysis of different metal ions in body fluids like blood and other samples, also urine, etc. And it can also be used for analysis of metal ions in water samples, as water contamination nowadays is major problem. So we can detect different metal ions present in the water so as to ensure whether it is fit for drinking or not. So atomic absorption spectroscopy can be used for that purpose. And atomic absorption spectroscopy can also be used for the detection of metal ions in different food products. So it can be used in food industry for food analysis. And another advantage of atomic absorption spectroscopy is that the molecular form of the metal does not impact the accuracy of its determination. Molecular form here means molecular formula. For example, we can determine aluminum content of a water sample simultaneously, irrespective of the fact that whether it is present as chloride, bromide, sulfate, nitrate or any other salt. Means all of the aluminum can be determined simultaneously. It will not be impacted by whether it is present in the form of chloride, bromide, sulfate, nitrate or any other salt. So these are the few advantages of atomic absorption spectroscopy. And next is disadvantages. So one of the disadvantage of atomic absorption spectroscopy is that we can determine only one element at a time, as by using atomic absorption spectroscopy we can analyze only one element at a time. So its disadvantage is that for analysis of the mixture it is not so much useful. Why? Because for analyzing a mixture we need to select the appropriate wavelengths each time and then analyzing individual element at a time. So we cannot determine simultaneously all the metals present in a mixture. For that we will need to study each of the individual metal at a time, so that would be time consuming. So that was all about atomic absorption spectroscopy. Thank you.